Okay, guys, today we're going to learn about chapter 11, triangles, quadrilaterals, and polygons. So this is considered as the basic shapes that you will learn after we learn about angles, points, lines, and also angles, points, and lines. Okay, and all the perks from previous chapter. Now we're going to learn for this meeting triangles and quadrilaterals only. Okay, and polygons will be learned later. Okay, because triangles and quadrilaterals are two basic shapes, the first two basic shapes. Okay, let's see. So our learning objective, you may be able to identify the different type of triangle, special quadrilaterals, and polygons, and state their properties, and solving problems including all the topics, all the shapes, triangles, quadrilaterals, and polygons. Okay, let's start from the first thing. Triangle. Okay, so as you can see in front of you right now, the triangles has three sides and three angles, of course, right? So three sides and three angles, that's a triangle. It can be anything, three sides. It can be nothing less unless three sides and three interior angles. Okay. What is the three sides? AB side 1, BC side 2, AC side 3. You can just switch it, side 1, side 2, side 3, anywhere. Okay, and it shows that they have also three angles. This is called interior angles. You have to write down like this. This is how you write the angle in symbol. If I write angle A, you have to write CAB. From A is in the middle, so this is for angle CAB, or BAC. A is always in the middle of the pair, three pairs here, or you can just write like this. Okay, look at this. Okay, the top side is supposed to be an angle symbol, or you can just write angle CAB or angle BAC. So what is this? So B is in the middle, right? So ABC or CBA, or you can just write angle ABC, angle CBA. And how about this? C is in middle, ACB or BCA, right? You can just write like this, or put on top of it, of the C, BCA on top of the C as well. Okay, make it sharp. But I advise you, this is my advice, you use this rule is better. Okay, you use this kind of writing. Okay, that's it. And now that's for the basic of writing down the angle properties. Okay, you symbolize the angle. Next, classification of triangle based on its sides. Okay, based on its sides, or this line, they have three kinds of triangles. First thing, all equal. All sides are equal. When all sides are equal, it means that it is called equilateral, or I think we have the simple way to memorize equal all. Equal all. So equilateral, equal all trial. See, that's how I try to memorize this understanding. Okay, now triangle with two sides, at least two sides. So when it is at least two sides, it is called isosceles. At least two sides, isosceles. Two sides are equal. And then scalene, none of the sides are equal. Okay, a triangle with no equal sides. And this is about the sides. And we have to connect the sides with the angle. How about the angle? The angle is here. So for equilateral triangles, when they have all sides are equal, they also have three angles are equal. You know the total angle on triangle, right? Sum of angles on every triangle is 180 degrees, right? This is for everything. Okay, every triangle has the sum of angles of 180. So when they share the same angles, you just divide by 3, right? So it has to be 60, right? 180 divided by 3. So 60 on each side, on each angle, because they are equilateral. So you memorize equilateral triangle, all sides are equal, and all angles are 60 each. Okay, keep that in mind. Let me know whenever you have any question. Now, how about isosceles? Isosceles triangle has two equal sides. So the base angle of two equal sides are equal. There you go. Let's say this is 60. No, not 60. If it's 60, it's weird. Let's say this is 70. So this also 70, right? So the rest will be 180 minus 70 minus 70. Okay. 180 minus 70 minus 70. So it is 40 degree. Okay. If this is x on the bottom, this also is x, right? Because the base angle are equal. Okay. So how about this? 180 subtract 2x. That's the rule for the isosceles triangle. Now, do the scalene triangle. Scalene triangle has no equal sides. It means has no equal angles as well. Okay, that's the rule. Because we can conclude that the comparison of the sides can be seen with the comparison of the angle. Okay, that's it. Comparison of sides equals comparison of angles. So if three sides are equal, three angles are equal also. If two sides are equal, two angles are equal also. This is for the equilateral. This is for isosceles, and one equal, nothing such one equal. The other will be scalene. Okay, that is what you need to know for now for triangle. Okay, I will copy this and I put it on Microsoft Word, and I put it on PDF as well, so you can see later on. Okay, now we're gonna learn about this. Wait, we're gonna learn the next part. Let's go for the next. Now the types of angles that they have. Wow, okay. We have, this is a different perspective. Previously we learned about the sides. Now we learn about the angle. Based on its angle, we have three also. Acute angle triangle. A triangle has three acute angles. Every angles are less than 90 degree. All angles are less than 90 degree. Okay. How about this? One angle is exactly right angle or 90 degree. Right angle is 90 degree. One angle. So this is called a right angle triangle. We don't talk about the sides. All sides are different. See, it might be same, but it might be different. Okay, but we are focusing on the angle. Now, obtuse angle triangle. Obtuse angle triangle, one angle is more than 90, but less than 180, of course. Okay, it cannot be more than 180 degree on one angle of triangle. Okay, less than 180 degree. So it is called obtuse angle, or in between 90 and 180 degree. This is the basic concept. One angle, only one, cannot be more. Can you imagine we have two obtuse angle on one triangle? This is first obtuse angle, right? And one more obtuse angle. Cannot, it might be, it's not a triangle at all. If you want to have one obtuse angle and it's enough for a triangle, see? There you go. Okay, cannot be more than two obtuse angles. Keep in mind. A triangle has a maximum obtuse angle on one triangle is only one, cannot be more. Okay, copy this. It's quite simple. Acute angle, everything or less than 90 degree. Every angle less than 90. Right angle, one angle exactly 90 degree. Obtuse angle, one angle exactly more than 90, less than 180. That's types of angle. Now, the sum of angle on triangle. This is recap. This is the primary topic, but I will give you the explanation about how do we know that one angle on triangle, total of interior angle or sum of the interior angle of triangle is 180. How do you consider that? How do you memorize or how do you understand that thing? I will give you one triangle. This is a triangle. Let's say this is angle A, angle B, and angle C. Okay. And what is A plus B plus C? Here, we will use the previous knowledge about angles. I want to draw two parallel lines with a transversal angle, transverse line. This is the first parallel line, and this also the second parallel line. See, and it has to be parallel, big the side. So I use the other color. If this is C, what is this? C also because it is alternating. Get it? So if this is C, this also a C. And if this is B, the A, if this is A, sorry, not B, I use the lighter color, blue, light blue. If this is A, this also an A. Why? Because it is alternating as well. So A and B and C, in this case, in this part, wait, there you go, is supplementary angle. What is supplementary? What is supplementary angle? They are add up to 180. So this is how you prove A plus B plus C is equals to 180. Okay, so we know that the sum of interior angles of a triangle is 180. This is the proof. Okay, see, alternate, and total is 180. So make sure that in every triangle, for every triangle, it can be scale-in, obtuse, right angle, acute triangle, isosceles triangle, equilateral triangle, every kind of triangle supposed to be add up to 180 degree because they are proven like this, alternating. Okay, now let's try to do the questions. The work example, no need practice. Wow, piece of cake. Now, how do you find the value of A in this figure? To find the value of A, you know that this side is 90 degree, right? That's the first thing first. So how do you calculate the A? Okay, just write 65 plus 90, right? Okay, all right, like write it first. Plus A is equals to sum of the angle on triangle 180, and this is 65 plus 90, 155 plus A equals 180, and A is 180 subtract 55, sorry, 155, right? And it is equals to 25. That's all. We get the A. How about this? Find the value of B. Okay, now what is this? This is, you have the sign. Two equal sign. It is called two equal isosceles. Isosceles triangle has the feature of two base angle are the same. This is the angle, the sides, I mean. So the angle, this angle will equals to the other angle with the same fit, the same length, angle with the same length. It has to be B also. Why? One more time. Base angle from the same sides are equal. This is the basic understanding that we already learned previously, just now. Okay. So write it down. Every angle, you add all the angles. 52 plus B equals 180. This is a triangle sum of interior, right? So 2B, right? Correct. Directly. 180 subtract 52, right? So 2B equals 128. So B, I put it here, because I don't want to waste so much time, so much place here. 128 over 2, 64. Done. Okay. The question is, Mr. Hans, I want to ask you, how about the isosceles triangle like this? How about if the isosceles triangle like this? This the base angle is this, the equal size. So which has the same angle? What part? Any answer? Can you just answer? Which is the same? Which are the same angles? Anyone? Hello. Which are the same angle? Same angle. If this is what is the same? Anyone can just unmute and let me know what angle are the same in this kind of isosceles triangle. Hello.
ACB and BAC.
Oh, wait. This is angle. I don't have any point, any angle, any letter. Just name it. Which one? Which two are the same?
The one with the
This and
with the line. Yes.
on the bottom, right? Right, bottom and top.
Yeah.
That's it. Why? Because this is the base, the same equal sides, not this. So this is the different, the other different. See? So this is 52 BB. So if I switch the triangle, I rotate the triangle as one as I wish, you can name the same angle. This is the same angle. Let's say this is A, this is A also. Okay. Keep that in mind. So don't get confused if I rotate the triangles. Okay, I will delete this because it's not our topic, but you know how to do it then. Next. Basic properties of a triangle. No need, no need, no need. There you go. So, as you can see, the basic relationship between angle and its opposite side. Look at this carefully. You can see the pattern. So, what is the pattern? As you can see, if A is it's based on the experiment. A is 65.6. It's quite bad for the number, but don't worry about that. B is acute angles. Everything is acute angle, right? 60 less than 90. Everything is less than 90. So this is called an acute triangle. As you can see, the ratio between the angles and the sides that is opposite of it, right? So angle A opposite is side A, angle B is opposite of side B, angle C is opposite of side C. As you can see right now, clearly seen in front of you that the bigger the angle, the bigger the side. See? So if you compare A with B, side B is less than side A. The greatest side has to be on C, right? Because it has the biggest side, biggest angle. So angle and side are two things that are interconnected one to another. So when the base the side is the greatest side has its opposite greatest angle. See? So it is directly proportional. So it is proportional. Okay, the greater the side, the greater the angle. The smaller the side, the smaller the angle. That's it. Okay, this is the pattern. I don't think I need to copy this. Yeah, you know, the greater the angle, the greater the sides. The greater the side, the smaller the angle, the smaller the sides as well. And next. Exterior angle. What is exterior angle? Exterior angle that is the angle that is outside of the angle, the triangle. So this. So you don't have to confuse between which part that you want to do. Okay, I want to draw a triangle also, this one, the different triangle, of course. I want to make this as weird as I can. I want to make extra line here. Wait, there you go, extra line, anything. You can extend here, or you can extend like this also, up to you. But I want to do what I want, okay, as I wish, and you can do it as you wish as well. Okay, here I can just write it like this. So let's say this is I. I means interior angle. Interior angle. This is interior angle. This also interior angle, right? Inside, interior. Interior means the angle that is inside the triangle. Okay, interior, let's say interior 1, interior 2, interior 3. So here you go. Where is the exterior? Exterior is the one that is supplementary with interior. Okay, supplementary of interior. So if this is interior 1, this is exterior 1, right? And if this is interior 2, not this, yeah, careful. The other, the supplementary, exterior 2. So this is the term only. This is exterior 3. So Q is the exterior, R exterior, P exterior, A, B, C are interior angles, right? So this is the exterior angle. So the exterior angle is always supplementary with the interior angle. Okay, that is the first rule. Next, we can go for a further topic. So an exterior angle of a triangle is equals to the sum of its interior angle of the opposite angle. For example, D. D is the exterior of B, right? Okay, just memorize. If D is the exterior of B, so you can write D is the sum of interior of two others, right? So D equals A plus C. I want to draw another triangle to make it simple, so you can see it clearly. This one. Let's say this is ABCD. No, PQRS. I want to use another topic, another letter, so you can understand. Where is the exterior angle? The exterior angle is S, right? It's outside of the triangle. So you can just write S as simple as this. Make it simple. This is a shortcut. S equals the other two interior. Other two interior. So it's supposed to be here, not R. Why not R? Because R is the interior angle of S. So just can write P plus Q. That's it. See how simple it is. So this is the rule. This is a shortcut. Oh, how do you memorize this? We have this. Okay. Now I will copy this also, so you can see the connection of one exterior to the other two. The two opposite interior. This is the interior angle. How about B? B is the exterior of B, so B is equals to C plus A, the other two. Okay, the other two, keep that in mind. Next. Oh, how do you calculate A? Oh, wait, no. We have to solve it. There you go. Practice now too. How do you calculate the A? A is the exterior angle of one triangle with the angle of this, right? So the other two is 48 and 53. You don't have to think too much, right? So A is equals to 53 plus 48. That's all. 101. Mr. Hans, I don't want to memorize this. I want to use another. I want to use the most basic way. No problem. Lihat ya, lihat ini. If 48 and 53, what is this? The interior angle. 180 subtract by the other, right? 48 minus 53. Okay. So the answer will be 180 minus 48 minus 53, 79. Okay, this is 79. And we can find the value of A. A is 180 minus 79, right? I can just use this, can I? Sure, no problem. They will produce the same answer, but this is longer. You need to find the other interior angle first, and then you have to find the supplementary of 79, wasting time. But again, you may do it. Okay, I will give you the options to do this. Now, how to find the value of B and of C? Okay, I think I can find the value of C because we already learned about C, about the exterior angle. So C, look at this triangle. So focus on the first triangle. This is the second triangle. And if we focus on the first triangle, we know that the angle of C is the exterior and the two opposites is 93 and 41. Okay, just add it up. And that's all. 134 degree. Done. How do you calculate B? Remember, B is on the second triangle, right? So we cannot find B unless we get this, right? The bottom. We have the connection. This is 93, right? The bottom is 93. So this will also 93 degree. Why so? Because it is vertically opposite. Remember the previous topic. So to find the angle B, so 180 subtract 33, subtract 93, you get the answer directly. Okay, 180 minus 33 minus 93, 54 degree. Okay, that's all for practice now. And this is the practice, and we go to exercise. But I don't think we can do it now, later, because we want to go for the quadrilateral formula. Okay, everything is so much, but I will give you some numbers only. Just focus on the other on what we're gonna learn for today. Quadrilateral. Okay, quadrilaterals. Look at this. This is a quadrilateral. What is quadrilateral? Four-sided shape. It has four sides: A, B, B, C, C, D, D, A. Right? And the total angle on quadrilaterals is always 360 degree. You don't have to prove this. We have two triangles, so this is total 180. This is total of 180 as well. So the total angle on triangle or on quadrilaterals is 360 degree. Memorize. Okay. The sum of interior angle on quadrilateral is 360 as it is shown on the graph right now on the book. Okay. Now let's go. Properties of special quadrilaterals. This is challenging. So much theory in this case. We know some of the special quadrilaterals. Some of them I can just write. It is square, rectangle, right? Rhombus. What else? Parallelogram. Whoa, so much. This is so much. Parallelogram. What else? Kite. What else? Trapezoid or trapezium. I don't know what is written here. Trapezoid or trapezium, it's same. I think that's all. Okay, square, rectangle, rhombus, parallelogram, kite, trapezoid. It might be one more, but again, we continue. Yeah, it has. I got 6 for now, but let's see. Yes, that's right. 6. Yeah, rectangle, square, parallelogram, rhombus, trapezoid, trapezium, and kite. Now, what are those one by one? Look at the sides and the angles. So please pay attention in this case. So for a rectangle, what is the spatial features? The parallel side, 2 pairs of parallel sides. Where are those? Here. 1 pair, left, right, and the second pair here. So not only this, because you can just write, oh, if I have 2 pairs of parallel sides, I can just write like this. This is parallel. And this is parallel also, right? But this is not a rectangle. Why? Because this is a parallelogram. So it has another special features. Equal sides, opposite sides are equal in length, as you can see here. There you go. Equal, it has to be equal. And this is equal also. And what makes the rectangle different with the parallelogram? All interior angles are 90 degree. Okay, keep that in mind, right angle. This is not a right angle, see? So we can compare between quadrilaterals of rectangle and quadrilaterals of parallelogram. Okay, and see the other thing, I think, oh, okay, we cannot zoom everything. Rectangle now, diagonals, 2 equal in length. See the keywords, 2 diagonals BD, right? The BD, see, that's a diagonal. BD and CA are equal, and they are bisecting. Bisecting means what is bisect? Bi is two, sect is sector, bisector, two equal sides. They cannot be different. For example, if this is 5, this also 5, cannot be 10, cannot be 7, cannot be the other 5, 5, 5, 5. Okay, and they are bisecting, means they share the equal, they have the equal share. Sama, 5 or x, for example. That is rectangle. But how about the square? Square has the same feature for parallel sides of rectangle. They share the same feature, see? But the equal sides, no different. Look, opposite sides. So opposite sides are equal for rectangle, but for square, all four sides are equal in the same length. And this also same. See, we can compare between rectangle and square. Rectangle and square, the difference only on the sides, not the parallel sides. The parallel sides are equal. They are two pairs of parallel sides as well. The difference they make is the length of the side. Okay, that's it. And the diagonals also equal in length and bisecting. And also another special features, the angle that is inside of it is 90 degree of the diagonal. Not this. This is an acute angle, right? This is an obtuse angle, right? So the another special features of the diagonals of the square is for all the bisecting or all the connected angle in diagonals, in two diagonals, are all equal, 90 degree. See? Okay, and bisecting this by 45 degree, right? Very simple. Square is quite this the most uniform. They have the most uniform features. Okay, that is for a square. Now let's go for parallelogram and rhombus. We compare two. Yeah? We compare two is better. Better we compare two. Okay, so parallelogram is like the move forward or the slant slant rectangle that you put the end, you pull the end of the point here, lu tarik gitu, jadi si tarik sini tarik ke kiri, ditarik tarik, jadi kayak rectangle yang lu tarik sini jadi ya miring gitu. Ya, very simple. Two parallel sides sama same ya, two pairs of parallel sides. So as you can see, you compare four, everything is same. Lu lihat deh. There you go. Nah, kelihatan langsung. Ini sama semua. Oke. Kalau ini sama-sama ini. See? Rectangle sides-nya yang sama. Kalau ini sama semua ini. Okay. And all four sides are in. This will be same. This will be same also. Okay. This also same. You can see how the pattern, yeah. This also same. Bisecting. See? So parallelogram is the inverted rectangle. Not inverted, apa? Is the pulled rectangle. Ditarik ujung sama ujungnya. Ini bisa begini juga dong. Bisa ya, nggak apa-apa ya. Agak gini. Nah, atau begini. Tarik kiri kanan juga boleh. Make sure that this is different. Okay, those two sides are different. Kalau sama namanya rhombus gitu. Okay, hati-hati aja, ini terminologi banyak. Terus ini juga sama nih guys. All sides are equal, see? Four sides are the same length. So, you bisa tanda-tandain di buku. Kalau you buka buku sekarang enak tuh, you tanda-tandain aja. Rectangle samanya, semua rectangle sampai rhombus, parallel sides-nya two equal parallel sides. Two pairs of parallel sides. Dan equal size-nya sama. Now, two more. Ya, yang lebih nggak ada aturannya. Trapezium is at least one pair of parallel sides. Udah gitu doang, nggak ada yang lain. Yang lain nggak ada kosong-kosong gitu ya. Piece of cake. Jadi ini bisa diconsider as apa? Coba lihat ya. Parallel size-nya gini. Oke. Ya ini trapezoid. Karena yang lain nggak ada paralel, udah itu langsung trapezoid, nggak ada yang lain. Kalau gini gimana guys? Coba ya. Sekarang mulai mikir nih. Ini apa? Ini trapezoid juga. Jangan pikir, oh ini kayak rhombus nih, mirip-mirip rhombus. Ya. Enggak, ini trapezoid guys. Karena ini beda, ini nggak sama nih. Not two parallel. Okay, only one pairs of parallel sides that make the trapezoid. Okay, yang bikin trapezoid jadi trapezoid itu cuma one pair of parallel lines. Nggak ada yang lain. And kite is very simple. The opposite sides may be parallel. Maybe. Jadi nggak harus. There are two pairs of equal adjacent sides. Okay, what is adjacent now? Adjacent itu sebelahan ya. Yang sebelah-sebelahan. Nih. Ini sama ini adjacent namanya, AD lanjutannya, AD and DC are adjacent. Dia sebelah, bukan opposite. Yang lain opposite loh, opposite. Ini juga opposite. Semua opposite ya. So hati-hati aja. Kalau yang kite adjacent, adjacent means sebelahan. And the diagonals is always 90 degree. Ya. Ini kayak lu gambar salib. Gambar salib kan nggak harus, kalau ini kan plus, nggak bisa ya. Salib itu harus somewhat lebih panjang. Satu side aja, ini sama. One diagonal equal, lu lihat. One diagonal bisect. Bisect itu equal ya. Bisect the other diagonal, and lu tinggal tarik begini. Itu namanya langsung kite. Terus salib biasanya kalau hadap atas, ya udah. Ini harus sama dong, nggak mungkin beda kan. Yang beda kan atas bawahnya. Atau lu mau terbalikin juga nggak apa-apa. Yang penting atas bawahnya beda. Lu mau kiri kanannya sama gini boleh juga. Ya. Yang penting ininya nih guys. This is the most important feature. And then they are equal on the bisecting or on the adjacent sides. Adjacent means sebelah-sebelahan. Okay. Now let's go to the word problem. Okay. How do you find this? This is a rectangle. Wait, no, practice now aja. Kita lihat ya. The figure shows rectangle E lies on AB such that ADE is 51 and DC is 68. Find AED. AED. Okay, it's quite simple. How do you calculate AED here? Ini kan rectangle. Kalau rectangle features-nya apa? Oh, ada. Ujung-ujungnya 90 gitu ya. Write it down. Ini 51. Ah, ini berarti langsung ketahuan. Ini triangle yang ini dong. Pakai triangle aja rules-nya. 180 minus 90 minus 51. The answer is 39. Oke, dapat 39 degree. CED. Oke, what is CED then? Lalu lihat, kita pakai helping line dulu. Ini kan 90 degree, ya. Berarti ini juga 90 kan? Bener nggak? Oh ya udah, lu dapat ini dong. 90 minus 51. Sama 39 juga. Ya udah, no problem. So, CED ini pakai triangle tuh. Gitu. So 180 for the total angle on triangle, subtract 68, subtract 39. Okay, that's the way you do. You need to watch the recording later on, because I just go forward and you might miss this explanation. So you can watch the video later on. Okay. Now the figure shows a rectangle where AC diagonals and intersect as at E. Okay. Given that ACB equals 63, we only have one clue, but again, no problem. Look at this. BEC, how do you calculate this? How do you calculate BEC? First thing, you know that the features of rectangle has two diagonals here, and the diagonals is bisecting, so it has to be equal, right? The diagonals are bisecting, so we know that this triangle are isosceles. So if this is isosceles triangle, if this is 63, the other base is also 63, right? So you can calculate BEC simply just 180 subtract 63. I just put this. I think that is better for you to also calculate. Okay, so the answer is 180 subtract 126. it is 64 degree, right? Slightly different. And CDE, okay, CDE. How do you calculate this?
Sir, it's 54.
54, thank you. Sorry, I did something wrong. 54, yeah, thank you, Karin. So how to calculate this? Use the third triangle. Not third, second triangle. Also an isosceles triangle, right? They share the same diagonal. So if we have this 63, we know that the rest is equals to this, right? 90 subtract 63, it is 27 degree. So we know that this is 27 degree also, right? CDE is 27 degree because it is isosceles with angle ECD. Okay, angle ECD is 90 minus 63. That's all. Okay. Quite simple for the rectangle. Now we go for the next harder part, square. Oh, why square can be harder? Because the question, wait. Okay, next. Oh, parallelogram. Make sure that parallelogram is very, very complicated. Okay, oh, we have so much space here. Nice. Practice now 3. I don't know what is practice. What practice now is this? Everything is practice now 3 in this case. So the figure shows, as you can see on your book, it's not a practice now 3, right? It's practice now 4 or 5, I think. The figure shows a parallelogram ABCD where ADC is 108, as given on the graph. E lies on AB such that BC is 38. Given ABC is 9x, ABC is 9x. So where's the 9x? It haven't been written. ABC, oh, here. Right? And find the value of x. Okay. How do you calculate this? This is 108. See the previous logic. Previously, we learned about the parallel sides and also its transverse. If this is 108, this is the co-interior, right? The interior angle. So you cannot find directly. Angle DAE is interior with 108, so 180 subtract 108, that's all, right? So 72 degree. Okay, we get it. DAE 72 degree. And DAE and ABC are interior as well, right? Look at this. They are interior also. So 180 subtract 72 is equals to 9x using this interior properties. Look at this. This and this. Okay. So 72 minus 180 minus 72 or 9x equals, there you go, that's better. 9x equals 180 subtract 72. So 9x equals 108. You can find the value of x, 108 over 9x, right? 108 over 9, sorry, not 9x, 12. Right. Okay, next. Let's go to the next question. Find angle DC and E, DCE. Okay, it is quite challenging, but we know that angle DCB, oh, this is for part 1. Angle DCB are also 72. How can it be? Because it is co-interior with 108 here. So DCE, sorry, DCB, part 2, yeah. Angle DCB, you have to look at the whole picture and the small picture, whole and big, small and big, that's it. Try to look on the other perspective if you are stuck. So DCB is equals to 180 subtract 108, so it is 72 also. You don't have to rewrite it by the way, but we know that angle DCE, so as you can see, the 72 is here, right? And this is 38. So DCE is 72, the big angle, subtract by the small angle 38. So it has to be 34 degrees. That's it. Now, question 2. Algebra. Okay, how do we deal with algebra? Calm. Look at this. Think properly. Yeah. If you look at this, it's quite hard. It's so complicated. But again, try to focus your mind. Think, what are those? This three, and we have three angles, right? So it can be 5x 6 and 2x 6 13. It is interior angle also, right? So sum up to 180. See, and this also an interior angle. Sum up to 180 as well. But the question is, which pair that you use? Any thoughts? Which pair that you want to use? This first pair, what I circle with black color, or this? Which one you want to pick? The red or black? The red pairs or black pairs? Guys, answer me. It has to be the black or red. Anyone? Please answer. Pakai yang mana, guys? Waduh, kok pada diem? No idea? Oke, ya udah. Kalau nggak tahu, you lihat, cari yang sama. X and X. Oke. So, ini yang hitam aja pakainya. 5x plus 6 plus 2x plus 13 are interior angle. Interior angle sum up to 180, right? So, ini 7x plus 18 equals 180. 7x plus 19, sorry, bukan 18. 6 plus 13, ya. 180 minus 19. 161. So the x can be get by 161 divided by 7. 23 degree. Okay. After you get 23 degree, everything is look simple. Ya. Nah, lo lihat yang kanan ini. Ini kan langsung ketahuan. We get the answer. 5x plus 6. 5 times 23 plus 6. So this angle will be angle ADC. 5x plus 6. You just substitute the x by 23. 121. Pure algebra. So angle DCB. So angle DCB is 180 minus 121 because it is interior angle. That's what we learned on the previous topic. So DCB berapa? Y plus 17. 180 minus 121. 59. So the y equals to 59 subtract 17. 42. Done. Oke, susah ya. Susah banget, tapi lo bisa pelajarin. Lihat pelan-pelan. Look at the video one more time. Oke. Lo kalau nggak nonton videonya, sayang. Nggak bakal bisa. Susah soalnya. Okay, I have to admit that this question is hard. Or hard. Now kita lihat ada triangle, ada rhombus, rhombus, ada yang lain-lain lagi. So pelan-pelan ya ini kita kerjain ya. Triangle and a rhombus. Nah, ntar exercise, abis itu selesai nih. Okay, practice now. Bukan 3 ya, kita bikin gini. The figure shows a rhombus ABCD where ACD is 32, AB is produced to E. Produced means diperpanjang ya, extended to E. AB is extended to E such that AC equals CE. AC equals CE. Wah, lu lihat nih ada triangle yang nyempil itu apa? Lu lihat ada triangle kan? Yang kayak motong, kayak intersecting, intervening, intervere the rhombus. Okay, everyone, I'm asking for your focus right now. So for those who get lost in focus, now focus. I will give you some time to think about this. I will pause the meeting. Okay, the figure shows rhombus ABCD where ACD is 32 as given. AB is produced to E such that AC equals CE. AC equals CE. Oh, it's an isosceles triangle. ACE, right? And find ABC. How do you calculate ABC? So first thing first, if this is 32, this also is 32. Because they are a rhombus. It is a rhombus. Rhombus means they share the same size, isosceles. And this also 32 degree. Why? Another isosceles triangle. And the features of rhombus is the angles are bisecting, equal angles. Okay, equals angle are bisecting. This is for rhombus, not for the other. Okay, special rhombus. So to calculate ABC, okay, it's quite piece of cake. Look at the triangle ABC, of course. This triangle. Wait. Okay, this triangle. Okay. And it has to be add up to 180, right? So 180 subtract 64. So 116 degree, right? Okay, now calculate BCE. Wow, BCE. We never know about BCE because it's a scalene triangle. So what you can do is try to find the other. Try to think of the other angles that can be found. This, right? This is 180 minus 116 because it is supplementary. So it is 64 degree, right? Oh, what is the 64 degree? And as we know, look at this point. What I am thickening is also a right angle triangle. Sorry, isosceles triangle. I want to make it thicker. There you go. There you go. There you go. Again. Wait, why I cannot put this? No, okay, sorry, so bad. This. Okay, a bit thicker, so you can see the triangle that is produced from my line. So this also an isosceles triangle, right? So if this is 32 on the left, the other base angle are also equal. Okay, this also is 32 degree. Next, how do you calculate BCE? You need to focus on what I highlight also here. This triangle. See, this triangle, the red triangle, is add up to 180 also, right? So BCE is 180, subtract 64, subtract 32, right? So 180 minus 64 minus 32. The answer is 84 degree. Okay, done. Now, this algebra. Okay, we deal with algebra so hard, but again, you still can manage it. Again, it's a rhombus. Rhombus means this is x plus 45, and this also is x plus 45 because the angle are equal. So the rhombus characteristic is this. All the sides are equal, right? All sides are equal. And also these features, the diagonal are bisecting at 90 degree. Wait, this is 90 degree. And this angle are also equal. Okay. So if this is x plus 45, this also x plus 45. And this is 90 degree. Okay, and we can see the triangle clearly enough. Look at the pink one, cute pink triangle. So if you add all the triangles, add all the angles, I mean, so 3x plus 13 plus x plus 45 plus 90 equals to 180 degree, right? So you can just write neatly, and cute 3x plus x is 4x. 13, 45, 90. 13, 45, 90. 148 equals 180. So 4x equals 180 subtract 148, 32. Why I can do this so fast? Because I get used to this. I already about almost 12 years to teach this class, this math, this topic, plus minus subtract multiply, division, you need to practice more in order to get fast. But some of you are faster than me because some of you find you use the special knowledge about the Kumon thingy or about the what you call the Sampoa and so on. You can just faster than me. Okay, but again, for the concept, I already experienced in almost 12 years. So no need to be too fast, but try to think and try to practice more and more in order to get the idea. Okay, to get the grasp the idea and fast and looking at this faster. Okay. Now there are some homeworks for you. You still have about 20 minutes to solve to do the homework, and I will stop the recording and I will send this to you later on in YouTube. So I'll see you later, guys. Bye.